All right, we're going to work on question 6 now. So the value of a here is 2. So we're going to try to find the equation of the line tangent to the curve at this location 2, comma, really 2.5. This is what they're looking at here. And so we need m tangent, which is the derivative of f, in this case evaluated at x equals 2. So the function f is right up here. X squared plus 1 over x. So we're going to find that derivative of this particular function, x squared plus 1 over x. Quotient rule now. X squared x, take the derivative of x squared plus 1 minus x squared plus 1 times the derivative of x. So as we take these derivatives, we'll get here 2x 1. So I get x times 2x minus x squared plus 1 times 1. X squared now, let's distribute this. Minus x squared minus 1 over x squared. So that derivative will be simply x squared minus 1 over x squared. So we have to evaluate this at x equals 2, which is really the a value, right? They're saying a is 2. So we're going to get m tangent by taking 2 squared minus 1 over 2 squared, which will be 4 minus 1 over 4, which is 3/4. So m tangent is 3/4 here. Now, the equation of the line tangent to the curve at the value, remember the point they gave us here was 2, 5 halves, which is 2.5. This is the location on the curve and written in the problem here. So let's do the algebra. So we get y minus y1 is m times x minus x1. Y minus, this is the one and only point. Here's your x and y coordinate. Y minus 5 halves is 3/4 x minus 2. So as we do the algebra, y minus 5 halves becomes 3/4 x minus 6/4, which will be 3 halves. So you might say, why did I want to convert that now? Because when we add 5 halves to both sides here, it'll make our arithmetic a lot easier. So that equation, the tangent line is y is 3/4 x, negative 3 halves over here, plus 5 halves. That'll be 2 halves, which is 1. All right. This is the L tangent, the equation of the line tangent to the curve at the location 2, 5 halves. This is that tangent line. All right. Let me see if I can bring that up over here, or at least copy it. And so I didn't draw the tangent line here. You know, it doesn't kind of look like that. I'm going to go to Desmos, 3/4 x plus 1, and share with you guys here, you know, essentially what's going on with the curve. Okay, this is the picture. Now, 3/4 x plus 1, if I do that, let me add a, can I add one? Okay. Y equals 3/4 x plus 1. I want you to see this here. Okay, that's the equation of the line tangent to the curve. I can change this color if you need it, so you can see every detail. That's the equation of the line tangent to the curve at that location, 2 5/2. So I want to share that with you guys. All right. Now, let's recall the second part of the questions they want to find is, do you have any horizontal tangents? And remember what you do. You set that derivative equal to 0 here, and you solve for x. So that derivative we got is right up here. All right. So we're going to set this equal to 0. We solve for x. Remember the logic I mentioned earlier? That if you ever have a fraction equal to 0, what that means is the numerator, which is x squared minus 1, must be 0. So we have to solve this for x. There's various ways to do that. I can use intermediate algebra by adding 1 to both sides and then use the square root formula, which will be x is plus or minus square root of 1. That now means x is plus or minus 1 here. So you got positive 1 and you got negative 1 here. These are values of x where you have a horizontal tangent that's at two locations. X is 1 and x is negative 1. So if I go back to the picture here and I erase some of the work we already had, x is positive 1. Okay. They're saying at this location here, you have a horizontal tangent here at x is 1. Let's highlight the value of 1 here. And then at x is negative 1, you have another horizontal tangent. Okay. So I want you guys to see the pictures of what horizontal tangents look like. Now, this is not the locations. To get the locations, we have to go back over here to the function now. And in the function, we're going to plug in the positive 1 and the negative 1. So if x is 1 now, this is really the y coordinate now. Will be 1 squared plus 1 over 1, which is 2 over 1, which equals 2. So this location is 1, 2. That's the location. This is what they're looking for. That's the location. Similarly, if you plug in now negative 1, wherever there's an x, negative 1 squared plus 1 over negative 1 gives you 1 plus 1 over negative 1 which is 2 over -1, and this is -2 now. So you got the y coordinate value being -2. So x is -1, y is -2 here. This is the location. That's what they're looking for number 6. All 3 of those kind of questions, okay? Now, number 7 here, we're going to go through the same thing, but notice this. You have a nice polynomial function, and at 1, 2, they ultimately want to find the equation of the line tangent to the curve. So in this example, a is 1. So, okay, this is the location they're finding. So we need m tangent at that point. And that's going to be the derivative of the function evaluated at x equals 1. So the function now again is x squared plus 1 here. A nice polynomial function. So let's get the derivative of x squared plus 1, which will be 2x. We have to evaluate that at x is 1. So this becomes 2 times 1, which is 2. So here's our m tangent. All right. Now, again, the location, if we're going to find the equation of the line tangent to the curve at this point, the point is 1, 2. It's the one and only point we have. Let's get out some paper here. At location 1, 2. Here's the x coordinate, the y coordinate. So we say y minus y1 is that m, really m tangent, x minus x1. So y minus 2 becomes 2 x minus 1. So y minus 2 is 2x minus 2. We're going to add 2 to both sides. So you get the equation of the line tangent to the curve. Y is 2x. Al tangent. So in Desmos now, I'm going to go here to this function to share with you guys y is 2x, how that looks. I'm going to change that tangent line to 2x. So as you can see here in the picture, this is the tangent line that is barely kissing the curve at the location 1, 2. And the equation is y is 2x here. Okay, this is what we're talking about. We just found that location. Now we want m horizontal tangents again. I'll abbreviate ht for horizontal tangents. Remember, you set the derivative of the function equal to 0. Solve for x. So what's the derivative of the function? Well, right here. So if I set that equal to 0, we'll do that. 2x is 0. I can solve for x, dividing both sides by 2. Now we get x is 0. Here's your horizontal tangent. That's the location of a horizontal tangent. That happens when x is 0. So we're talking about when x is 0 over here now. And I guess we'll still use red. X is 0, the y coordinate becomes 0 squared plus 1, or y is 0. So that location, if they say what's the location, they mean both an x coordinate and a y coordinate. It happens at 0, 0. It's where you have your horizontal tangent. All right. Number 8. Finding the slope of the tangent line, and then eventually the equation of the tangent line here. A value is -1 here. So a is -1. Your function will be x squared minus 2x. So let's find m tangent, which will be the derivative of x at x is -1. X squared minus 2x. Okay, let's get that derivative, and it's 2x minus 2. We're going to evaluate this at x is -1. So don't know what's going on here. Let's try to... Okay. Let's plug in -1, and you get -2 minus 2, which is -4. Here's m tangent, -4. Equation of the tangent at the location -1, 3. So here's the location. Y minus y1 is m times x minus x1. So this is the x and y coordinate of the one and only point. So it's what you see here. Y minus 3 is -4 x plus 1. And y minus 3 is -4x minus 4. We're going to add 3 to both sides now. Y is -4x minus 1. So here's the equation of the line tangent to the curve at that particular location. That's our tangent. Let's put that in red. -4x minus 1. So what I'm going to do here, okay, let's copy that. Put it back over here so you guys can see this. I'm going to now draw that line there. Y is -4x minus 1. -4x minus 1. Let's go to Desmos here so I can demonstrate to you guys. Let's double check here. Sure enough, yes, you can see that this is a tangent to the curve, barely touching, barely kissing at -1, 3. We're now going to try to locate horizontal tangents now. So when you try to locate a horizontal tangent on this curve, remember this. You set the derivative of the function equal to 0. and you solve for x. Two x minus 2. Add 2 to both sides. You get 2x equals 2. Divide both sides by 2, and now you get x is 1. That's only part of the story. This is the location of a horizontal tangent here at x is 1. So if I said to you, well, where's that location? This is where x is 1. So the x coordinate is 1. We need the y coordinate. It looks like the y coordinate is going to be -1 in this picture. But how I know for certain is I go back and I plug 1 here for that x. So y is going to be 1 squared minus 2 times 1, which means 1 minus 2, or it just simply equals -1. So y is -1. And sure enough, when x is +1, y will be -1. This is the location where you have a horizontal tangent. L tangent. That's what we're looking for. Number 9, the location they're looking for here, we're going to find m tangent, slope of the tangent line, and the equation of the tangent line. That happens here where a is 1 now. The function is going to be 1 over x. So using our definition, m tangent f prime x evaluated when x is 1, that derivative of 1 over x. Remember, this is x to the -1. So by power rule, it's -1 times x to the -1 minus 1. It's -1 times x to the -2. -1 times 1 over x squared. Just -1 over x squared. That's your derivative. Okay? So we have to evaluate this. Remember, this is at x is, I believe, +1, or a is 1. There it is there. 1, 1. A is 1. X or a, same thing. -1 over 1 squared is -1 over 1. It's -1. Here's your m tangent. Slope is this point. Now remember, the location, we got to get the equation of the line now tangent to the curve by taking y minus y1 is your m tangent x minus x1. I'm just leaving this in, the beginning algebra format. So this is x minus 1 is -1 times, take that back, y minus 1, -1 times x minus 1. We're going to distribute this. It's -x plus 2. That's the equation of the line tangent to the curve. This is going to be what we're talking about up here. This is the equation of the tangent line. I didn't even draw the tangent line because I'm going to go to Desmos and show you directly. Negative x plus 2. There we go. I wanted to go to Desmos and show you guys directly that that's the equation of the line tangent to the curve at the location 1, 1. That line is barely touching, barely kissing the curve at that location. All right. Where is the horizontal tangents? Set the derivative of the function equal to 0, and then you solve for x. So the derivative, go back here, is right in here. This is the derivative of the function. Negative 1 over x squared is the derivative. So we say we're going to set this equal to 0. Negative 1 over x squared is 0. Again, this is rational. And that only happens, any fraction equal to 0 will only happen when the numerator is 0. But the problem is, this is a contradiction. 1 could never be 0. It's not the same number, which means this fraction can never be 0. Which means you have no horizontal tangent. Okay. No horizontal tangent. Number 10. They want the equation of the line tangent to the curve at the location 4, 2. So we need m tangent at this point. And this is now a is 4 here. Okay. And your function now is going to be the square root of x. So let's use that definition of m tangent. M tangent is f prime x evaluated at x equals 4. That's your a value. So this derivative now of the square root of x, and I'm going to put this here. I've been leaving it off, but you guys know what I'm talking about. Remember, I said to you guys, you want to memorize this definition. Even if you didn't, just use the power rule. But this comes up a lot. This derivative comes up a lot. Okay? That's the derivative. Evaluate this at x is 4 now. 1, 2, square root of 4. Square root of 4 is 2, so 1 times 2, 1 over 2 times 2 becomes 1/4 here. M tangent is 1/4. Okay. The location, remember, is 4, 2. So I'm going to write that down. This is the one and only point they give you. So by using beginning algebra, y minus y1 becomes m times x minus x1, or y minus 2 becomes 1/4. Looks like x minus 4 now. Okay. So y minus 2 is 1/4 x minus 1 when I distribute here. So when I add 2 to both sides now, I end up with the equation y equals 1/4 x plus 1. All right. That's the equation of the line tangent to the curve. So let's bring that up here, this equation. Then we'll show you the graph. One-fourth x plus 1. There you go. That's the equation of the line tangent to the curve at that particular location now. Let's find horizontal tangents. This occurs when your derivative is 0, and yes, you'll have to solve for x. We just got to know what's the derivative of this function. The derivative is right here. It's 1 over 2 square root of x. So we're going to set this equal to 0. Now remember, whenever you have a rational function and it equals 0, what that means then is your numerator must be 0 then. So the only way a fraction is 0 is if the numerator is 0, because 0 divided by any number would be 0. Now, you notice this is a contradiction. 1 could never be 0. This is impossible. That means there's no horizontal tangents. So, ladies and gentlemen, this is the demonstration. I will send this to you all. And I hope you guys enjoyed this presentation.